2.7, modeling with functions. We're going to find a function that describes the dependence of one quantity on another, and that's called modeling. And we'll be using algebra and geometry properties. We're building a box for cake mix, and it must have the following proportions. We're told its width is 3 times its depth, and its height is 4 times its depth. So everything is reliant on depth. So depth is our x. Its width is 3 times its depth. So width is 3x. And its height is 4 times its depth. So height equals 4x. So we're going to write a function modeling the volume of the box in terms of its depth. So volume of a box, volume in general of a rectangular prism is length times width times height. So for this, volume of x equals x times 2x times 3x, which simplifies to 6x. I'm sorry, totally did that wrong. X times 3x times 4x, and we simplify that to 12x cubed. We are now being told to find the volume of the box. If its depth is 2.5, so depth is 2.5, so that makes 2.5 equal to x. So we plug this in and go 12 times 2.5 cubed. We can use our calculators, cube 2.5, multiply it by 12, and we get the volume to be 187.5. For what depth is the volume 80 inches cubed, cubic inches? So that means our volume, our total volume is 80. And we have to get there by 12x cubed. So divide by 12 first. And 80 divided by 12 becomes 6.6 repeated equals x cubed. To solve for x, we have to cube root both sides. And there is a function on your calculator to do this. If you need help, let me know. So we get x to be 1.88 inches. For what depth is the volume less than 75 cubic inches? So this becomes an inequality. So volume cannot be greater than or equal to 75. So volume needs to be less than 75. So 75 so we plug it in and we see 75 is greater than 12x cubed. Divide by 12. 6.25 is greater than x cubed. Cube root both sides. And we get x is less than 1.84, which makes sense because when it was 1.88, our volume was 80. We want 75, it's a little bit smaller. So our guidelines for modeling with functions, we're going to express the model in words, choose variables, and put everything else in that term of variables. Set up the model, which is creating a function. and then use the model or the function to solve the problem. Okay, so Sam has 50 feet of fencing to fence in a play area for his puppy. We're going to A, find a model to represent the amount of area he can fence in. For B, for what range of widths is the area greater than 825 square feet? And for C, find the dimensions of the largest area he can fence. So, for part A, says find a model to represent the amount of area he can fence in. We're going to assume it's going to be rectangular. And we know on a rectangle, area equals length times width, and perimeter equals 2L plus 2W. To fence the area, we only have 140 feet of fencing, so our perimeter total is 140. So we substitute in 140 for perimeter, so we get 140 equals 2L plus 2W. Let's simplify everything by dividing by 2. So we go to 70 equals L plus W. Okay, so we want to know the total area. We know area equals length times width. So we need to solve for one of the variables in our perimeter. So let's say length is one we want to solve for. So length equals 70 minus W. So we're going to use this in our area formula. Area equals length times width. Plug this in. Area equals 70 minus W times W. So all we need to do is distribute, and our area is modeled by the equation 70W minus W squared. Part B says for what range of widths is the area greater than 950 feet? So now it becomes an inequality. So we want our area to be greater than 950 feet. So we want values where 950 is less than 70W minus W squared. So we could solve this by getting all terms on one side and solving the nonlinear inequality, or we could use a graphing calculator. And what a graphing calculator, we would make sure to set one equation where y equals 70x minus x squared. Equation 2 is 950. So we want all values where the curve is above. So our curve. Will look as such, and then we will have our straight horizontal line at y equals 950. We need to find out what these two lines are, where they intersect, and those would be our solutions. These intersections occur at 18.5 and 51.5. So x is less than or equal to 51.5 and greater than or equal to 18.5. For part C, it says find the dimensions, the largest area he can fence. So that means we need to find our maximum. So we're still using our area formula where it's negative x squared plus 70x. We need to find our vertex. Negative b over 2a. So negative 70 over 2 times negative 1. This goes to 35. So now we need to find the area at 35. So it becomes negative 35 squared plus 70 times 35. So it equals 3,675. This is the maximum amount of area that could be enclosed.